Welcome to Vision to Venture. I'm Eddie, and I'm here to uncover the realities of scaling and building a tech startup. Each week, I speak to leaders within the tech space with their insights and advice on how to found, fund, and frame a tech startup. So make sure to follow and subscribe to never miss an episode. Hello, and welcome to another episode of Vision to Venture. Today, we're joined by Malte Kleine, head of machine learning at Sonar. Malte's career path is unique. Not only did he transition into machine learning without a formal data science background, but he's also leading innovative projects in smart city technologies like traffic management, parking solutions, and privacy-sensitive sensor systems. His work impacts urban infrastructure across Germany and beyond. Hello, Malte.
Hello,
Welcome to Vision to Venture. Thank you so much for joining me today. How are you?
I'm fine. Thanks for having me.
Absolutely. It's an absolute pleasure. I've been looking forward to getting into this. So I just wanted to start off by talking about your journey into machine learning. You transitioned into the field without a formal data science background. What were some of the biggest challenges you faced making that leap, and how did you overcome them?
Okay, it's a complicated field, it's a complex field, and it's a fast-moving field. I mean, it's not rocket science, but there is still a lot of math involved, so that was probably the biggest challenge. Um, to overcome it, I think the most important thing is to have fun while doing it. You have to learn a lot of things, you have to try a lot of things out, and if you're not having fun while doing it, I don't think you will succeed. For me, I find it just fascinating, machine learning in general. And I also like the practical aspects. Like, where do I get my data from? Like, how can I bring my data in some kind of form where it can be used in a machine learning context? Um, that's just immensely fun for me. And that definitely helps a lot because then it's easy to spend a lot of time on it. Additionally, I think that the hurdle to actually get into machine learning is relatively low, especially compared to other programming fields or tasks, maybe. For example, you don't have to install GCC and then add the path to your environment or something like that. You can right now go to tensorflow.org/tutorials and train in Google Colab, a classifier network with under, I don't know, 30 lines of codes in maybe 15 minutes. Um, of course, that doesn't make you a machine learning engineer and much less a good one, but it's possible. It's a starting point, and you can do that right now from your mobile phone, even. So that's what got me into it, like
Oh,
the
wow.
low barrier of entry, and then just trying it out, working with it. And my suspicion is, especially when I talk with people at job fairs or any kind of other get together with machine learning guys or data scientists, that a lot of them are not doing that. Um, I heard, I don't know, 1,000 times, a million times, the sentence garbage in, garbage out. Um, but when you actually ask the people, then, okay, what actually constitute as garbage? And how do you clean your data set? Or how do you get your data set in the first place? Um, then it gets a lot more difficult and complicated. And I hear a lot less. And that's, I think, like a practical approach that's needed for machine learning. Because, okay, if you can't feed even garbage into your machine learning network, then it's not that important that you know that you shouldn't do it. Like, don't get me wrong. Um, I think that like knowing the theory behind it, like how to normalize a data set, how to remove bias from a data set is immensely important. But the practical parts are equally important. For the theoretical parts, I read a lot of papers, and I read a lot of papers that claim that this paper is the only paper that I need. Um, I haven't figured out which one it is because there are so many that claim exactly this, but the promise is at least there. Um, but maybe importing conf2d from tf.keras.layers is bringing you already quite a long way. there on what you can do with machine learning networks, especially if you're working on the edge like I do. Like I don't have models with a bazillion parameters that explode the moment you do backpropagation. It's a lot simpler and that's learnable. Um, After getting into the field and after actually getting a job, I still had to overcome my imposter syndrome. That was actually quite a big challenge. And I did overcome it simply by talking with other people, smart
Okay.
people who are working also in the field.
Yeah.
And my experience is okay, they running into the same problems as I do. They struggle with the same stuff as I do. And they also don't have answers for the many, many questions I then ask them. So I guess at the end of the day, we all cook with water and we all import NumPy as NP.
I mean, I feel like that's the best way to learn anything as well, especially if there's something that's so new to you. And the fact that you've basically taught yourself here, which is absolutely incredible. I feel like the next best thing is talking to people in that field and just getting to know stuff. Like obviously, I feel like I feel like it's a field, it's an area that you're always learning. And
Yes,
you're
and for that you have to be interested in it, right?
yeah,
You have to ask questions. You have
yeah.
to learn and read new articles. Otherwise, you will be your knowledge will be outdated in 1 or 2 years, probably.
Exactly. And it's that sort of field where you're never going to know everything. No
True.
one's ever going to know everything. So you're consistently learning new things, which I guess obviously for someone like yourself, where you obviously have this really strong passion and interest for it, it's always just going to be exciting because there's always something new that's going to
Yeah,
come about.
maybe ask me in 10 years if I'm still as excited, but currently, yes, I'm very excited about machine learning.
Absolutely. There's so many new things happening now, so many new things that are coming out, and even for somebody who isn't particularly in machine learning or a machine learning engineer whatsoever, even I find it interesting just talking to experts in the field about these things, through the pod or through obviously recruiting or whatever. It's even that side of it is interesting. So coming from someone like yourself, I don't blame you for asking those questions and finding out these new things.
I will
Um,
never excuse me for asking questions. I think that's not just for machine learning, that's in general, I would say.
There's
Good
nothing
approach.
wrong. Yeah, exactly. So at Sonar, one of your core focuses is detecting and classifying vehicles using sensors. These handle different applications like parking, traffic, and even environmental monitoring. How do you ensure that these sensors can perform across such diverse use cases without compromising on performance?
I guess that's like the big promise and the big strength of machine learning as a field itself, like the generalization aspect. Like the same algorithm that can detect vehicles or pedestrians and then classify them. The same algorithm can also like detect non-biodegradable trash, for example, plastic in some form of container. Sure, like you need different data sets for it, and the models then have different weights, but the underlying algorithm is basically the same. And you always have in the back of your mind like this general problem. Okay, I can brute force everything with machine learning if I just have the right data set. Um, and with that in mind, it makes it a lot easier to focus on that. Um, but of course, like traffic, different kinds of use cases is always every new project is a new challenge because new projects have like different kinds of accuracy requirements or inference time requirements. For example, it has to be this fast or this accurate. And in the end of the day, we just have to test it. We have to try it out. Does it work? And for that, I really like the very tangible space that is computer vision in traffic management, especially if it's a project that's close to Aachen, like the city where we are residing. Because at the end of the day, when I struggle with something, I can just go there under our
Yeah.
sensor, look at the real world, and then use curl to get the data from the database, and then make with my own eyes and my own mind the comparison. Okay, what's the real world and what is our model saying? And if it's not matching up, okay, I have to go back and fine tune it and fine tune it. But if you then actually succeed and you have a good feeling about it, that's like a huge feeling of accomplishment. If you're standing at a crossroad and you think, okay, my models, like they have a good idea what's happening now and I can actually get the data from the server. Um, so in that case, I guess this retrying and testing and error, that's not too different. My workflow is in that case not too different from like the actual machine learning algorithms, like constantly improving and yeah,
A lot of training.
a lot of training, yeah, and yeah, a lot of retraining because oftentimes like the first time, the first model usually doesn't work. There's
Mm.
something strange that I didn't account for. There's something weird going on in the real world that you just didn't have in mind and you didn't see it in your data set. No way around to actually look at the real world and use your natural intelligence to get to get the next steps from the conclusions.
Does that ever get a little bit tedious, consistently training, or is it just all worth it when it eventually works?
I think the actual training is like rather small part of the work, right?
Oh yeah. Okay, fair enough, fair enough.
Um, it's
Um,
more everything around it, like the pipelines and getting the data and normalizing the data, which we just spoke about, and then
yeah.
have it all in some kind of efficient pipeline. The actual training is just then, okay, pressing enter on a script or something like that. It's, I don't find it tedious.
Well, I mean, yeah, you have a huge passion for machine learning, so that's fair enough. I don't wouldn't expect you to.
It, it
Now
may
a
sound
lot.
stupid, but I really like when I see in TensorBoard or in any kind of console output, when I see during the training that the loss goes down and the accuracy goes up at
Okay.
the same time, it gives me like this very primitive and very simple dopamine rush. Like, okay, how far down can the line go? Like, how far can the accuracy number go up? And if I change something, like, can it even go higher? And,
Almost becomes like a game.
yes, yes, and like I'm easily motivated by like simple things like that.
Now, a lot of your projects are publicly funded, and because of that, the technical specifications can be seen by the public. How does this level of transparency influence your approach to innovation and development?
Okay, like number one, I think is like bullshitting doesn't work. Um, we have to be very open about, especially like limitations of the software or our solutions in general. And then in turn, I have to be very realistic about what can be done with machine learning and how it can be done and with what accuracy. And if the requirements change from the public side, then we also have to be very open if that is a problem. And what we consider the possible solution to be. Um, that is very important. Like we can't really over-promise stuff because at the end, a real person will look at the data and then it all falls through. Um, I think there's like the tendency in marketing and especially in tech and even more, especially in the AI space, like to promise the world and then some more. Like my machine model learning models will not solve the traffic issues in cities. Like there's no way around that, and I'm very realistic about it. But at the same time, because I know what it can be realistically done, I also know the advantages. Like I know that we can use existing infrastructure better, and I know that we can use these models to better use the existing infrastructure. Um, and if I overpromise something, like I basically have to do overtime, and I don't want to do overtime, so I usually don't overpromise. Um, there's like this internal company meme. It's called "Never Let Malte Present," and it comes from like a demo day, a presentation that I had relatively shortly after I joined, where we also presented like a trash detection system to decision makers and the broader public. And I was quite nervous. And while talking about the system, I fumbled a little bit and was more focusing like on the shortcomings and the possible room for improvement, and not the strength of the project, which then lead to like the marketing guys or the sales guys saying, never let Malte present. But at the same time, the same customer also called us 2 years later for a new project. And we were very open about this project and said, that sounds like kind of difficult. Like we actually don't know how long it would take us to even consider this. Like we don't know how good we can solve this problem. And they still wanted us to participate in it because like we were from the start very open and honest about the project. And they then get the feeling that we do everything that we can do to deliver the best system available. And that's what we are doing in the end. That's, I think, the biggest thing that's like the transparency can give you.
And how does public accessibility impact competition or collaboration?
I don't really know if it impacts it that much. Like in the end, I think both the public sector and the private sector always want like the best product for the lowest price. That doesn't matter if it's publicly or privately. For these big public projects, you sometimes have the case that you are part of a consortium. That you're working together with partners who are like technically also a little bit competitors of yours. And you still have to work together and be like very honest about your solution and the solution of your competitor. Because if you're not choosing the right solution for the public offer, then you both lose money. And if you're realistic about it and can deliver, then you both win money. So in that case, there are more possibilities for like a win-win scenario, non-zero sum game, basically. I quite like that, but I have to say I'm a bit too removed from the business aspect to realistically judge it if it's more common in the private or in the public sector. But for me personally, this thing, the approach that we are mostly working with public money, gives me personally motivation because we are often working in Germany and I pay taxes in Germany. So I don't want my taxpayer money to get wasted. And if it's somewhere outside of Germany, it's still probably funded through some EU project. And I really don't want to waste that money, even if it's a small amount. And when I speak to friends or family about public projects that I'm part of, I don't want to think that I don't want them to think that I'm wasting their money, basically. I want to be able to justify everything I do at work. And I think I can do that. But that only works if you have constantly in your mind, like, is this really the best use of my time? Is this really the most efficient use of my resources? So in that case, it can help to maybe make processes more efficient and to judge your workflow. But I'm very well aware that this is like purely a mindset question, that there are probably a lot of people working in the public sector who are not doing it like that. But yeah, I always have like an intrinsic motivation. Okay, do it efficiently, don't waste money. In the end, it's your money. And from that money, the city could also build maybe a new bike lane or something like that. So I really have to justify it.
Yeah, I mean, I feel like you're right about obviously if it's publicly or privately funded, it's just about having the best product for being built the cheapest way, isn't it? So I guess that's obviously true. Um, you operate mainly in German-speaking countries
Yes.
where privacy regulations are particularly stringent. With that in mind, how do you balance the need for data collection with privacy protection in your projects?
Okay, so we are GDPR compliant from the start. GDPR is basically the law that forces the website to display the cookie banner that
Yeah.
you always click away. and 90% of them are illegal, but that's something different. So for us, we do have like intrinsic motivation to collect as few data points as possible, simply because mobile internet in Germany is very expensive. Like we can't stream videos. That's not possible. Like if our
Really?
yes, like if our business model would be to stream a video and then send it over the ocean and then have it analyzed, I don't know, on Jeff Bezos' mom's A100 cluster or something like that, that would
Ah,
not be a viable approach. Like the company would be bankrupt in a matter of days, not weeks, but actually days. Like there's a cost point to every single
wow.
image that actually gets sent over the internet. And we are usually having like contracts for 5 years or so. So like 1 megabyte a day is noticeable. It would be better if it were less than 1 megabyte. So yeah, with this video streaming, I don't know if that would be GDPR compliant, but that's not a question for me in the first place. Like instead, all the inference happens on the device or devices in our
Yeah.
case. Like the cam feed goes directly into a machine learning model with like some post and pre-processing, and at the end, there's like an array that comes out of it with some numbers that represent like the parking situation or the traffic flow situation or the number of entries or exits to some specific area. And it's not a problem at all to send this array then over the internet and have it in the database and make it accessible indefinitely because there's no personal information attached to it. We're not collecting that in the first place. Um, Quite often, the police actually comes to us and writes us a mail because some kind of crime happened where our sensors could have probably seen it. Um, the answer is always the same. Like, we don't have the data. We can't give you the image data from that time. Like, I can tell you how many cars parked there while the crime happened, but I can't tell you who did it. Um, Likewise, like if, I don't know, Joe Schmo asks us, okay, I want under GDPR, I want to get every information you saved about me. Here's my number plate, here's my car. Um, Maybe for some other tech companies, it would be very difficult and time intensive, but for us, it's like quite easy to answer that. Like, we have no personal information saved about you, and then you don't have to worry that much about GDPR. Um, for training, it's a little bit difficult because there you have to take image data, right? So we take training data from projects and customers where we are allowed to do so, and then only test where we are not allowed to do so. But they are also at the same time, we are not training the machine learning models in 4K, but in much, much lower resolution. So we immediately take the images that we send over the internet in a much lower resolution. So stuff like number plates or facial features, like everything that could be problematic from like a data collecting standpoint, um, we are not collecting in the first place. And we do have like a very good motivation to not collect the data simply because it costs money. Um, so yeah, I would say GDPR compliance is a lot easier if you are not trying to collect and monetize and resell every single piece of data you can get your hands on. And because of that, I'm actually quite a big fan of GDPR. And personally, in my work, I don't see it as a big obstacle.
Mm. I had no idea that's what it was like in Germany for like sending photos and stuff. Feel like we must take it for granted here.
I mean,
Um,
our sensors also work with the internet, and I can also on my mobile phone, yeah, I can send images over
of
the
course.
internet,
Yeah.
but it's like I don't know, it's a lot more expensive than
Yeah.
in other countries, especially other European countries.
Which
Um,
is crazy because
that
I'm just
like
used to it.
for us, like looking at like image sizes, like and counting the images and then calculating back to like megabyte space, that's actually noticeable in costs.
Yeah. Yeah.
It's not like that you have a flat rate and can have like 200 gigabytes of data for, I don't know, €5 or something. It's much, much, much more expensive than that.
Wow, that is yeah. Because I feel like whenever I'm doing that and sending like pictures to people or whatever, I don't take any notice in it. I'm just like, yeah, there you go, send them all. Here's 400
Same.
photos.
Like in my private work, I also don't worry about that.
Yeah, yeah,
But like our sensors are online 24/7, and
yeah.
they have to constantly analyze every new frame that comes in. And for a solution like that, like it becomes really noticeable after
Wow.
seconds or minutes even.
That's crazy. Um, so many of your projects need to deliver results with minimal delay. What are the key factors in ensuring real-time performance for machine learning models in critical applications like traffic management?
Okay, I think there are like two facets to the questions, right? One is like you want to minimize the time between a setup of a sensor and giving like the front end or the database to the customer. Like the time to actually train the models is relatively short. And then there's also the problem with the very limited processing power that our edge devices have. Like I said previously, everything happens on the edge. Um, and maybe I should go a step back and first talk about the limitations, because whenever I talk about the technical specificalities, I always get like the question, oh, why are you not using PyTorch? Like, why are you not using an accelerator on your device? Like, why are you not plugging in a TPU? And it's not that easy, because all our devices are outdoor and they have to work with like limited electricity supply, sometimes with batteries or sometimes with solar power. So even like the 5 watts or what it is for the Jetson Nano, it doesn't sound like much, but it is a lot for our sensors. And even if we would have like a stable electricity connection everywhere, it would still not be viable, because this small amount of 5 watts extra electricity, that's 5 watts in waste heat. And all our devices are hermetically sealed because they have to stay dry for 5 years and longer. Um, so there's like a very hard limit on waste heat we can output with our algorithms, and therefore there's like a very hard limit on the actual processing power that's available. Um, for the training time, to reduce the training time, we have tested and proven pipelines, basically, where we now, okay, we have done that half a year ago. Like we can do that again, slightly different. For that, we use DVC, data version control. I was not a fan when the head of software asked me to implement it, because I saw it as another level of complexity. But now, after using them a little bit, yeah, I really like DVC. If you are working with data sets and experiments and model trainings, you can probably profit from DVC. Um, but I'm not in any kind of shape or form affiliated with them. Just another project that I'm also not affiliated with is TensorFlow, even though
Okay.
I'm ranting a lot on their forums or on their GitHub pages, because their project management is just horrible. And I would rather use PyTorch, like all the cool kids do. But because of the limitation that we have to run it on an ARM CPU with very limited processing power, we have to use TF Lite models. Because from what I know, and you can please write me a mail if I'm wrong about this, but there's really nothing faster than full integer quantized TF Lite models, if you're working in an ARM CPU. And yeah, okay, then we kind of have to work with it. I know that the conversation, the conversion of different model types, like from PyTorch to TensorFlow or to some other library like JAX or ONNX, has gotten a lot easier, especially in the last years. And you could theoretically work with PyTorch and then convert it. But we are not writing custom layers or anything like that. Like we are using proven architectures that are already implemented, and the end product is a TF Lite model. So for such a small team as ours, it makes sense to then have everything in like TensorFlow. Um, that's like I think the technical aspect of it. Does that answer your question?
Absolutely, definitely does. And so obviously with most of your sensors being deployed outdoors, how do you handle environmental challenges? Why would you say this affects the accuracy and reliability of your models?
Yes,
Like,
yes, of course, it affects the accuracy. Um, I
surely.
I honestly don't sleep well in the nights before like contractually obligated counts. The cities sometimes do, because I worry. Like, if the weather forecast says it's sunny the next day, then I hope that the sun doesn't overexpose our images. And if it's cloudy the next day, then I really hope there are no strange shadows that could look like vehicles on a TDU
Mm.
projection. And if thunderstorm is forecasted, I pray that the lightning doesn't strike our sensors. Because yeah, you laugh, but there's a big
It
difference.
could happen.
Yes, yes, between unlikely and
It could.
impossible. Yes, it is. It could.
Yeah, it could.
Like
It's definitely something you should worry about.
like everything with a probability greater than zero can happen sooner or later. And like in these nights, I really hope it happens later and not the next day. Like for example, if the good people of town, I don't know, XYZ, all decide in the morning that the preferred mode of transportation is to ride around on on unicorns.
Wow, that'd be
Um,
nice.
yeah, we probably have problems because that's definitely not in my data set. And I don't know how to solve that. Like, I often see posts on LinkedIn or other blogs where people basically do very similar stuff to what we are doing by simply like putting YOLO on a drone and then flying on top of a parking lot, and then you see all the nice bounding boxes, great. Um, but most of the time these videos are like very idealized. It's always the same car with the same color. You look perfectly down from the top. Um, it's always the same color, shape, model. They always neatly park between the lines. And yeah, okay, then it probably works like that by just taking like a ready to go model and put it on a drone. But we are not flying drones 24/7.
No,
Instead,
of
like our
course.
sensors are mounted on poles, and then you have like occlusion and obstruction and like perspective issues and stuff like that. And then it's rainy and you don't see anything and it's dark and you have to look around the corner or something like that. And that makes it like hugely more complicated. Um, and what that's like the actual challenge in yeah, supplying these models with a high accuracy, like close to 100% accuracy, because you always have like some crazy eventualities that you didn't think about, but it can happen. And another way, like people are idiots, especially if they are like um, driving a car or riding a bicycle or participating in traffic. Um, I'm also a little like I also don't follow all rules when I'm participating in traffic. I don't know how it is for you. If you wait on every red light or if you park directly in the lines. I don't know. Everyone at home, I think, can think a little bit. But
Yeah, it's the same here.
yeah, and
I mean,
you have to work around that. Like you make the assumption, okay, people follow the rules, but they don't follow the rules, and then you don't see anything because there's moisture on the dome of the sensor, and then yeah, the model has to be really perfect to actually give a working system.
yeah, yeah, that's completely fair enough. I mean, and it's like what you're saying, like people park, like uh, people don't do the same thing every single day, especially when it comes to obviously parking in lines and crossing the road at a certain time. No one's gonna for things like that. You're always gonna have those people out there, especially when it comes to parking a car that think I'm better than everyone else. I'm gonna park in the middle of it, in the middle of the lines and cross two spaces and make
Yeah, and then
because yeah, that
if a car parks between two parking spots, like are both occupied? Is none of them occupied? Is one occupied? Like, are you counting cars? Are you
exactly.
counting empty space? Like, it always depends.
Exactly. Given the unique challenges of outdoor deployment and privacy concerns, how do you scale your machine learning solutions across different cities or regions, especially with varying regulations and infrastructure?
Yeah, like previously, regarding the privacy stuff, we talked that they are GDPR compliant from
Yes,
the start.
yeah, we did cover that briefly.
I think that's like the most difficult law to follow when it comes to
100%.
machine learning. So we don't have to worry that about that because we already do that. It doesn't
Okay.
matter if we are in Australia or Croatia, they probably don't have more strict laws. And Croatia is also in the European Union. Sorry about that. So um,
But
that definitely puts pressure away from that. Then the underlying algorithms, they don't struggle that much with different infrastructure. Like my machine learning model don't care if you drive on the left side of the road or the right side of the road because every training sample was flipped during the training horizontally either way. So it's the same for that. If the infrastructure is not there, we can't do much about it. I like the internet coverage. Like our devices are IoT devices. If there is no stable internet connection, then they are just things, and we can't do anything about it. It's way out of scope for us to build like a 5G mast or something like that. But of course, then if everything's working and you have internet, it's still like we talked about it. There are like million different cases, million different ways a crossroad can look like, million different ways a car park can look like, and then you have a million different cars or car types that can park there. Um, so yeah, you have to a lot of diversity in the data set right from the start, and you have to kind of know um, what common pitfalls could be. Like you have to know your data. For example, I would say around 90% of cars are either black, white, or gray. Like that's not the exact number, but roughly like
yeah.
basically cars don't have color anymore. Like that's all cars are boring now. And it's even worse if you're not working in the public space, but have like for some company the parking space because then all cars are gray. Um, and
It
you
is.
would
They all are.
think, yes, you would think like that detecting a red car against a gray pavement is something very easy. And with traditional approaches, with traditional CV algorithms, it is very easy. You just look at histogram or something like that. But if you never have a red car in your data set, then these machine learning's algorithm like suddenly struggle with things that should be really easy, but then are not because there are so many edge cases and eventualities, and their data distribution looks really weird. And it always
Oh.
changes depending on the location. Um, I think you just have to have that in mind, and a lot of that comes down to experience. I know now, okay, cars are boring. I have to make sure to have interesting cars in my data set. um,
Cars have got boring. They really have. I mean,
yeah,
you don't see any, yeah, you don't see any like, but it's funny because even me when I'm looking for a car, I would only ever look for grey, white, or black. Um, and I'm like, why? Why didn't I do that? And I don't know if you when you was younger you used to play this game as well. But when I was younger, whenever we'd see like a yellow car, we'd hit each other, and it would be like because
yes,
you
yes,
don't see it
yes.
very often, so you just hit each other when you see it. I still do play it with my partner.
Okay.
When we're on a long drive, it's like, yeah, yellow car, no return, and it's just like, well. You know what? Eventually get my dream car, I'm gonna get a yellow one because
Yeah, please do, and
yeah,
please send me a picture so
I
I can put it
will.
in my data set.
Because
Because
not
yeah,
only they, yeah, oh, exactly, you can put it in your data, and not only will there be another more, just not another boring car on the road, I'll also have satisfaction that out there somewhere, when I drive past, people are going to be hitting each other, and I want that. And it's even though if it's just for a game and it's just out of the laughs of seeing a yellow car drive past. It's still it that's but you're right though, it's so boring because you go to a parking lot and it's like I have a white car, my partner has a black car, and we go to the parking lot and we're like, where are the cars? Because they're all the same.
yeah,
I
and
don't remember I parked.
Machine learning models learn then, okay, cars are boring and gray and white, and that's what they learn. Like, I'm not hitting my colleague if I'm seeing a yellow car in the data set, but I tag it. I absolutely tag it because it's so rare that it's necessary to have in there.
Yeah, yeah, I think you should start. You should make it an office game.
And go around hit people if I see like a yellow car.
And if you see a pink, it's twice, 2 hits.
It's
Um,
funny, but I honestly think in my more than 2 years at Sona and working with like tens of thousands of car samples,
mm,
I don't know if I saw a pink car even once.
really? I
I don't
mean,
know. Like
that's
I would
why,
probably remember it. Honestly, I would
yeah,
remember it because I take these images.
that's why it's worth 2 hits because it's so rare.
Ah, right. One hit in the database and one in person.
Exactly.
I I will start now with
Yeah, I
that.
mean, and speaking of the future, looking ahead, just final questions before we wrap this pod up. What's your vision for the future of smart cities? Like, how do you see technologies like the ones you're developing evolve over the next, say, decade?
I would like to see more traffic flow measuring and
Okay.
less parking spaces. I completely get why the cities are interested in parking spaces. After all, like parking spaces are assets, and it's always like the hot topic in local politics. I guarantee you, if you open your local newspaper, the bad parking situation at some location is probably currently in your city, wherever you are, a big topic. So I completely understand why cities focus on parking first, but it's my gut feeling that like the more long-term solution to actually look at the traffic flows um, and then try to optimize the roads a little bit more efficient and do the city planning on hard data and not just, I don't know, which NIMBY group is the loudest. Um, that's something I would like to see more, and I know that it's happening a little bit. Like there are like the first research projects currently underway, where we were also part of it. For example, for ambulances, it
Mhm.
makes sense to measure the real-time traffic flow, even if like the left lane, the left road compared to the right road is 5 seconds faster. For an ambulance use case, it still makes sense to look at it because 5 seconds can make the difference between life and death. Um,
Absolutely. Of course it can, yeah.
I would like to see more of that, and it's happening slowly. But yeah, of course, like public projects, they're always like slow, right? So you have first a research project, and then a few years later, maybe you have an actual project about it. So I'm relatively certain that it will come, and I would really like to see it because I think in that will help everyone in the city if we are a little bit more efficient in the traffic. Um, in a much broader sense, I hope, especially with AI and machine learning, that smart cities don't do the same trend that social media is doing, which is hyper focusing on the individual and not the broad trends. Like having an algorithm that's specifically for you and then try to enrage you and monetize that as good as possible. In a smart city context, it would be like looking at number plates, for example, and looking at the movements of individuals. I really hope that cities don't do that and instead look at the broader trends because it's needed. Um, I learned working with parking data that most of the parking spots are empty 2/3 of the time. That's roughly the number, and only used 1/3 of the time. And it makes sense if you think about it, right? Because if you're at home, you need a parking space at home. But at the same time, all your neighbors are home and they also need a parking space right next to you. And if you're at work, you need a parking space at work. But all your colleagues are also at work and also need a parking space. And if you want to go shopping, all the other people that also just came from work will also want to go shopping. Um, and then there's not enough parking spaces anymore. And it is such a waste of public space So I really hope that we learn to use this space that we already built
Yeah.
more efficiently.
Yeah.
And I think machine learning and smart cities and sensors can solve it a little bit or mitigate the problem, because you will never solve the problem if you're just subsidizing demand. Like, you can build a million parking spaces, will probably not solve it, but you can spread the demand. For example, if you know historically the parking spaces at the shopping center you want to go are full now, but probably are empty half an hour later, you would probably go half an hour later. And then suddenly there are enough parking spaces for everyone. But you actually need the data in the first place, and you have to make them accessible for the citizens in, uh, in a very easy and convenient way. So yeah, I think there's a lot, really a lot to learn from machine learning, especially if we're looking at the generalization aspect and the broader trends. Because ultimately, I think that's where machine learning is good at, right? Like,
Mhm.
not focusing on one specific, but on the general stuff. Like, during training, machine learning models are forced to be as efficient as possible, like to store as much information in as few parameters as possible. That's, for me, basically what AI is at its core. And that can be very useful in public spaces or in smart cities. Maybe we can learn something from it. Like, it's maybe from all the artificial intelligence hype that's going around now. Maybe we also get a net positive of natural intelligence out of it. I'm 100% certain that it's possible. So let's try to do that.
Fingers crossed. And hopefully people start getting a little bit more creative with their car colors.
Yes. Buy a colorful car, but please stay inside the line.
Yeah, yeah, and that as well. Yeah, stop taking up two spaces. You don't need two spaces. It's just unfair on everyone else. But yeah, I completely agree. And on top of all of that, just st people just stop driving everywhere. You don't need to, like unnecessarily as well, because it's like, so obviously nowadays, like people are getting, obviously you've got all the like the kids and the teenagers that are all learning to drive. There's going to be more and more and more and more people like just driving, getting on the road. Well, thank you so much for everything today, Malte. It's been an absolute pleasure and incredibly interesting to learn
Yeah,
about.
it was a lot of fun. Thanks for having me
I
again.
really enjoyed it, thoroughly enjoyed it. Thank you so much. It's been, yeah, thanks for joining. It's been an absolute pleasure. Appreciate it. Thank you for tuning in to this week's episode of Vision to Venture. If you're listening, make sure to give us a 5-star review. And if you're watching, like and subscribe to listen to more inspiring stories from leaders in the tech space.